So what we're going to do now is look at the method for evaluating these definite integrals. Here's the one written out. There's a lower bound of -1, an upper bound of 1, the function that we want to find the area under, and our dx symbol, which relates to the small increase of x needed to produce the result that we're looking for, the area under the curve. So here's the method. You rewrite this using square brackets, but inside the square brackets you're going to put the antiderivative of the function. Then we're going to take the lower limits and the upper limits, feed them into this new function, this antiderivative, and calculate the area between those two limits. So we write it out like this. We're going to have one area, and we're going to have a second area, and we're going to subtract 1 from the other. This one is going to be the upper bound, and this one here is going to be the lower bound. So now each of these bounds has got its own little box. We now take the 1 and we place it inside these functions here. So x squared when x is 1 is 1. 3x when x is 1 is 3. And we subtract. We now repeat that process for the negative 1. Negative 1 squared is 1. Minus, and then we've got -1 times 3, which is -3. This is going to collapse to a plus sign. Let's just work that out. 1 minus 3 here is -2, minus the contents of this. 1 minus -3 is 4. So our final result is -2 minus 4. So the area underneath that function between the limits -1 and 1 works out to be -6, which sounds like a strange number. How on earth is it possible to have an area which is negative? So I'm going to explain that a little bit more clearly in the Desmos sequence which follows on from this video. So here we are with the Desmos software. Here's the function we were looking at. Function x is 2x minus 3. And this bit here in the curly brackets afterwards is the domain for the function. Those are the limits that we actually apply to our function. So here you can see on the chart that function is plotted between the values of -1 and +1. And we can also see now on that, if I open that up, this is the antiderivative plotted. X squared minus 3x on the same domain between the values of a and b that we've chosen. So now we want to take a look at where we are shading. All of the shading that you can see there is below the x-axis. So all of that area is negative. So between a equals -1 down here and b equals 1, the area is negative because it's below the axis here. Also notice that this line of the derivative, the blue line of the derivative, what is its difference? Well, here it's -2, and up here it's +4. And the slope is negative. It goes down to +4, 6. So the actual change in the height of the antiderivative is the same as the area under the curve. Here, the computer shows that it is actually equal to -6.